Well, I'm lead author on a UNEP report that we're going to release tomorrow called The Policy Implications of Warming Permafrost. The basic idea here is that there's 1,700 gigatons of carbon in permafrost in the form of frozen organic matter. And as the temperatures go up, that permafrost is going to thaw out. And if the permafrost thaws out, so will the organic matter, which will begin to decay and then release carbon dioxide and methane into the atmosphere. This will effectively amplify the warming due to burning of fossil fuels. And one of the main findings in our report is that you have to account for these emissions from thawing permafrost when you negotiate emissions targets in the treaty. If you don't account for it, there's a risk that you're going to overshoot the 2-degree warming target, which is the basis of the entire treaty. So we have 3 recommendations in the report. The first recommendation is recommending the IPCC have a special assessment report focusing just on permafrost emissions. And in the report, we evaluate potential permafrost thawing into the future. We try to quantify how much carbon dioxide and methane emissions there would be from thawing permafrost. And then most important, to include projections of future climate that account for permafrost carbon emissions and the permafrost carbon feedback. Our second recommendation is that individual nations with permafrost take over the current networks that monitor permafrost. The basic problem is that the current networks don't have enough sites and can't fully monitor permafrost degradation. And so we recommend that the individual nations consider taking over the sites, expanding the funding, increasing the coverage especially.
And which countries have permafrost?
This recommendation applies to all countries with permafrost, but most especially to those countries with the most permafrost, which is Russia, Canada, China, and the United States.
Right, okay.
Our third recommendation is to plan for adaptation. Permafrost contains a lot of ice, which acts like cement, which binds the soil particles together.
Right.
So permafrost is very hard, very tough, very resistant to erosion. Of course, if you thought of permafrost, the ice changes to water and the permafrost changes to mud. And so that means anything built on top of it has the risk of basically collapsing. So there's a lot of human infrastructure, buildings, bridges, roads in the Arctic, and if the permafrost thaws, there's a risk that this will be damaged, we'll have to replace it. So we recommend that individual countries with permafrost create national plans for adaptation. And in these plans, you identify at-risk human infrastructure, and then you engage scientists and engineers and economists to evaluate the costs and risks and mitigation strategies to deal with the impact of thawing permafrost on human infrastructure.
And give us an idea, people watching this at home who might not understand what could trigger this. What kind of temperatures are we talking about which could see the permafrost starting to melt, and are there, however qualified you have to be, are there certain timelines that people have in mind?
Well, the permafrost has already begun to thaw.
Right.
Along the southern regions of the permafrost domain, certain areas the permafrost has disappeared completely. So the southern margin is starting to march forward. What we're seeing in the future, for example, if you just have a 2 or 3 degree global temperature rise, you might lose anywhere between 30 and 60% of all the permafrost in the northern hemisphere, which is a significant loss. So in answer to your question, it doesn't take much to trigger some thawing.
And in terms of the implications of this thawing, is the main concern a huge release of methane, or are there other implications? You mentioned foundations of houses and those particular consequences, but is the release of methane the main concern?
Yes, especially for this conference here today, that is the main concern, because it directly affects how you negotiate the emissions targets in the treaty. Of course, if you're living in areas with permafrost, you're much more affected by the roads collapsing and disappearing than perhaps the emissions of carbon. But that's a local effect. That's why we recommend the plans for adaptation to deal with those impacts.
And I guess the final point, when people talk about tipping points, is this one of the major tipping points which scientists believe could, I guess, lead to irreversible climate change and increasingly, I guess, violent weather systems?
Yes, this is a classic climatic tipping point. Once you start emitting the carbon from the, let me say that again. Yes, it is a classic tipping point. Once the organic matter that's currently frozen thaws out and decays away, there's no way to put the carbon back into the permafrost. Once the permafrost thaws out and the emissions start, you can't turn it off. They tend to persist, or at least we feel that they will persist for centuries.